Okay, good morning. Yesterday we were talking about weed characteristics. So we want to move on to other issues. Okay, let me admit somebody. Right. Just a recap on what we were doing yesterday. Yesterday we focused on weed characteristics. And we referred to Becker, I think in 1975, who listed about 12 probably traits which describe weeds. Then we expanded on these traits, getting more examples about these weeds. So we should know the characteristics of weeds which separate them from other plants. This is what we covered yesterday. We also tried to define the weeds. Let me admit someone. Okay, I'm trying to admit some people. Okay, we defined weeds as simply vegetation which we find in agricultural or let's say in cropping fields. So it's simply vegetation which we find in agricultural fields. There's also an evolutionary way to look at weeds or to define weeds. These could be other plants. Or these could be ruderals. Or competitive plants. Remember, there are two approaches. So today what we want to look at are three things. So today we want to focus at three areas. Number one, we want to look at weed seed dispersal. This is simply the movement of weed seeds. The other thing we want to look at is weed seed bank. Then we also want to look at weed seed dormancy. So let us start with this weed seed dispersal. Then probably around the 12 or yeah, we have finished. Yeah, morning. Alright. Because I didn't want to teach. Okay. But Rachel will be told.
Na 10 late.
Dream.
Oh, alright.
It was the mask. masikati
masikati
yeah.
saka indo kusira
munogona muchiisira muningi ndova tichitako
yeah.
Hello, sorry for disturbance. So I was saying we are going to move on to talk about the seed dispersal. So with the seed dispersal, what is it? This is the movement of wheat seeds from the point of production to other areas. So this is basically the movement of wheat seeds from the source of production. The source of production is actually the plants themselves, which we call weeds, which have gone into flowering, then they go into seed production. And you have a seed movement and dispersal mechanisms. Now the causes of seed movement are basically three. We have got abiotic and biotic, then agronomic. Abiotic consists of the action of wind and animals. Wind and rainfall. This is the abiotic. The biotic involves the animals. So we will start with wind. The term which is actually used is anemochory, to refer to wind effects. Hydrochory, this is the movement of wheat seeds due to rainfall. Biotic causes, which are classified as zoochory, this involves organisms which are capable of dispersing seeds by adhesion. Seeds can stick to the animal skin or even to human clothes. This is epizoochory, or it could be through ingestion, endozoochory. Now, dispersal carried out by ants is not very large. It's classified as myrmecochory. Then there is a self-dispersal where you have a splitting of the fruits of the plant, which is known as autochory or ballistic dispersal, which involves barochory and pseudoserotin. These are just terms which are used. Then anthropochory, this involves humans, which act as fundamental drivers of dispersal. we have a horizontal seed dispersal mechanisms. This is what we call anemochory, or just wind seed dispersal. This depends on wind speed. If you don't want to use these terms, just use the simpler term wind. Or if you want, you can use anemochory. Most of the weed seeds in Zimbabwe are likely to be dispersed by this method, by wind during the dry season. For example, like this current period, we could have wheat seeds which are being moved around by the wind from place to place. A result of wind-driven aerial movement can actually redistribute weed seeds. You need special type of weed seeds with certain features. These weed seeds resemble parachutes. For example, Conaiza species. Some weed seeds can have wings or plumes that aid flight. So what you are saying is that for the weed seed to be carried by the wind, it should have certain features which allows it to float in the air, like a parachute, like a feature, or it could have some wing-like structures which can aid flight. This is Conaiza albida with those fluffy seed heads. Actually, they have parachute-like structures. Agimon mexicana, let me admit somebody. Sorry for that.
Doc, on this side, ndichiri paslide rakanzi biotic causes. I'm not seeing the weeds you are mentioning.
What about others?
Yeah, I can see Agimon mexicana.
Yeah, someone is seeing, someone is at the right slide. Is it not your system there?
Yeah, maybe my system or the network is poor.
What about others? What are you seeing? Hello?
I'm seeing Mexicana.
Okay, so I think it's your system.
Yeah, okay, let me try to use YouTube maybe.
Yeah, if you go to YouTube, I am live there.
Okay, Doc.
Yeah. Okay, so we're talking about features which can aid floating of these weed seeds in the air. Milenis repens is also seed heads which can easily be carried by the wind. Now we move on to the effects of water, hydrochory. Now water can actually transport weed seeds around. At the onset of rains, Of course, this may involve some erosion. So we have got seeds which are transported by water runoff or by floating along water drainage channels. It could be irrigation channels. This form of dispersal is likely to be common during the rainfall season in Zimbabwe, probably around, should we say around November, when we get the rains. So weed seeds capable of floating in water are transported to other areas. Or we can have a splash seed dispersal by raindrops. Let me check, there could be somebody again who wants to join. Right, raindrop action, but this is to a very small extent where you have the movement of the seeds by raindrop action. Epizoochory, this is very common where you have seed adhesion to animal fur. Seeds may have certain features which enable them to stick to the animal skin. So the animals which are involved, things like cattle, horses, donkeys, sheep and goats, probably cattle, donkeys and sheep, goats, which are commonly used in smallholder farming areas, which can roam about the fields as they graze. Like during this period, they also move around with seeds. To a certain extent, wild animals are also involved in this type of spread of weed seeds. So the seeds should have special characteristics which make them attached to the animal skin. Let me admit someone again. So I was talking about, seeds which can get attached to the animal skin as the animals move around. They spread these weed seeds. The examples of weed seeds which are adapted to this type of dispersal, we have Xanthium strumarium. Then we have got Bidens spirosa. We have got Tribulus terrestris. We have got Acanthospermum hispidum. Xanthium strumarium seed. This is what it looks like. It has got those hooks. And it can easily get attached to the animal skin. I'm sure it can cause, because it has some thorns, I think it causes some irritation. And the animal will try to remove it, and during the process, the seed is dispersed. Tribulus terrestris seed. This is common in, I think, natural region 3. You can see those spines. It can pierce somebody or animals. And of course, the reaction is to remove it and throw it away. It becomes dispersal. Biden spilosa tsine, you know, it has got those hooks. And if you move in a field with this weed where infestation is high, you end up with a lot of seeds on your clothes. Same applies to the animals which move through such fields. Acanthospermum hispidum seeds, it also has those spines, and it can aid this weed to be dispersed by sticking either to animal skin or to clothes. Setaria verticillata seed head. Again, this one can be very difficult to remove when it sticks to your clothes or animal skin. It's a grass which is common in agricultural fields. Endozoochory, we are now talking about seeds which are eaten by animals. These could be birds which eat the seed. For example, Thomas in 1970, who was studying the biology of Rotbolia coccincainensis at the weed research team, he found that guinea fowl and cattle, livestock, were involved with the dispersal of Rotbolia coccincainensis. Because these birds, guinea fowls, could eat a lot of seed. Cattle also grazed this grass. Rupend also found that Leucine indica was associated with the manure application. So cattle could aid the dispersal of Leucine indica. This one is a minor dispersal, minor coccory or dispersal carried out by ants. The distances involved are probably 2 to 5 meters. And we have Datura stramonium seeds, which are known to be dispersed by ants, as reported by Ben Venuti in 2007. Now, these seeds have got elysum. It's a chemical which can attract ants, and in the process, the ants end up distributing these seeds. Ballistic autochory is where we are having a fruit which explodes or which splits and it disperses seeds forcefully from the fruit. Maybe you know about this. You might have seen plants which can split, especially during this period. In fact, it's common with some trees with pods. They can actually crack and drop some seeds. This also same applies to some weed species. But short distances could be involved around the mother plant. Datura stramonium can also do this by splitting its fruit and broadcast the seeds around the plants. Cliomonophylla mujakari, spindle pod. It has got elongated pods, which when mature they can also split and scatter the seeds around the plants. What is known as barochary is not a true dispersal mechanism because of the absence of any device for moving the seed away from the mother plant. Seeds actually remain inside the plant. They are in an open calyx in the apical zone, or they are just inside the fruit. This may prevent seed predation. Examples are Chenopodium album or Amaranthus erythroflexus. This is Chenopodium album. Then another term known as pseudoserotin. Probably this may not apply to the actual weeds. The phenomenon of seed retention in the closed, usually woody fruits or cones. Seeds are protected from also predation. These are other plants, and probably they may not be applicable to weeds. Humans are involved with a lot of seed dispersal. This is known as anthropochory. Agronomic activities, working with implements. You have seed adhesion to the tires of operating machines. It could be clothes or even animal skin of draft power animals. Combine harvesters used on several farms could end up, dispersing weeds from farm to farm. Coming. Yeah. The leg changes. Probably after 12. Sorry about the disturbance. So I was talking about combine harvesters, which are used on several farms, which can end up dispersing weeds. We also have application. Let me check something. Right. Now, application of manure could spread the weeds, such as Elusina indica and Amaranthus hybridus. This was reported by Rupende in 1997. Strike acid can contaminate crop seed, and if we sell that seed due to seed trade, we end up spreading these weed seeds. Actually, the presence of Chenopodium album which we find today in Zimbabwe, came through wheat seeds from Europe. Now, seed movement within the soil is very limited. We can have a seed burial depth, which is linked to germination. It affects buried seed availability. That is mediated by phytochroma in photosensitive species. So we are talking of this vertical movement. So deeply buried seeds may actually be affected by lack of gases, a term which we call hypoxia, or inadequate gas exchange. This can actually inhibit germination. Soil tillage operations can also influence the distribution of weed seeds, but within the soil profile, this is very limited movement. Minimum tillage systems, we have the weed seeds which are concentrated near the soil surface. However, conventional tillage where we use the plows could result in uniform mixing of weed seeds in the soil profile. But on heavy soils which crack, the cracks could facilitate the movement of weed seeds down the soil profile. There are some weed seeds which can bury themselves in the soil. For example, wild oat, it has got a certain structure which, if it is wet, it can uncoil itself and drive the seed inside the soil. Probably you are aware of certain grasses which do the same thing. Burial also accounts for the weed seed longevity and dormancy, which we will talk about. We have talked about weed seed longevity. We also have the activity of earthworms, which can bring buried weed seeds to the soil surface, but these are very short distances which we are talking about, and which are happening within or in situ in the same field. A similar weed seed movement has been attributed to beetles. So insects can move around weed seeds within the soil profile. Ants also act as agents of weed seed vertical movement. But this is not movement to great distances. So the vertical movement is also it is also happening within weed seeds. If you want more information on weed seed movement and the dispersal strategies in the agricultural environment, you may have to read this reference, Weed Biology and the Management. It is well written. You may understand the movement of weed seeds. And with that, we come to the end of this weed seed dispersal.